Hello, it's Mr. Obi from GCSE Physics Explained. This video is about radioactive decay. By the end of this video, we will have covered these learning objectives: how alpha, beta minus, beta plus, which is called a positron, gamma and neutron decay occur, know how the atomic number and atomic mass is affected by the above 5 different types of decay, know how to balance nuclear equations in terms of mass and charge for alpha and beta radiation. Understanding the basics of nuclear equations. Nuclear equations are used to represent radioactive decay. Students are not required to remember specific examples of nuclear equations, nor the names of daughter elements formed, but students do need to know how to balance mass numbers and atomic numbers for nuclear equations. Remember, the mass number is the top number. It'll be the biggest number in all cases except for hydrogen. It's represented by the letter A. It tells us the number of protons added to the number of neutrons. The atomic number is the bottom number. It's represented by the letter Z. It tells us the number of protons. This number is sometimes called the charge number when balancing nuclear equations. The symbol for the element is represented by the letter X. Becoming good at balancing nuclear equations is easy if you remember the following symbols. Symbols for the 5 types of nuclear radiation. The symbol for an alpha particle is this or this. The symbol for a beta minus particle is this or this. The symbol for a beta plus particle, called a positron, is this or this. The symbol for gamma is this. The symbol for a neutron particle is this. Learning the mass numbers and atomic numbers for these 5 radiations will help when balancing nuclear equations. Now let's look at balancing nuclear equations involving alpha decay. Here is an example to show alpha being emitted from an unstable nucleus. When an unstable nucleus emits an alpha particle, it loses 2 protons and 2 neutrons. So, the mass number of the nucleus decreases by 4 and the atomic number decreases by 2. To balance the nuclear equation, the number on the top of the left of the arrow must equal the numbers on the top to the right of the arrow. In this example, let's check the mass numbers balance. 215 plus 4 equals 219, so the mass is correct. The numbers on the bottom to the left of the arrow must equal the numbers on the bottom to the right of the arrow. Let's check the atomic number or charge number balances. 84 plus 2 equals 86. That's right. Rules for alpha decay. Mass number decreases by 4. Atomic number decreases by 2. Here's an example for you to try. Pause the video and have a go. Here's the answer. Balancing nuclear equations involving beta minus decay. During radioactive decay of an unstable nucleus, a neutron can split up into a proton and an electron. The electron is ejected from the nucleus at high speed. This is the beta minus particle. The newly formed proton stays in the nucleus, so the mass number of the parent element is the same as the daughter element, but the atomic number now increases by 1 because the atomic number is the number of protons, which has just increased by 1. Let's check the mass numbers balance. 14 plus 0 equals 14, correct. Let's check the atomic numbers balance. 7 plus minus 1 equals 6, correct. Rules for beta minus decay. Mass number stays the same, atomic number increases by 1. Here's an example for you to try. Pause the video and have a go. Here's the answer. Gamma decay. Gamma is just pure energy. It has no charge and no mass. See how the emission of gamma energy had no effect on the mass number or the atomic number, but did calm cobalt down from its excited state. Gamma is usually given off during nuclear rearrangement following the emission of a different type of radiation. Rules for gamma decay. Mass number stays the same, atomic number stays the same. Beta plus positron decay. In beta plus decay, a proton turns into a neutron and a positively charged particle with negligible mass. The positive particle, called a positron, is ejected from the nucleus at high speed. Neutron decay. If a neutron is given off, the atomic number of protons, stays the same, but the atomic mass decreases by 1. This creates an isotope. Remember, an atom with the same number of protons but a different number of neutrons. Summary. Here's a table to summarise how each of the 5 different types of radiation affect the atomic number and mass number of the unstable parent element if they are emitted during radioactive decay. The table shows the type of decay, the symbol for the radiation, and the change in the mass number and atomic number of the daughter element compared to the parent element from which the radiation was released. Hit the like button if you found this video useful, and subscribe to my channel if you want to see more content like this. Work hard, be nice, and bye for now.